Today we're going to shoot a 45-70 500 grain SABOT round.
Wow. I think I like shooting that way better.
Huh.
Today we have an interesting design by Michael Smith, who has submitted stuff in the past like the Blue Falcon. This time he has designed a 45-70 SABOT round for a 12-gauge shotgun. As I'm editing this video, I realize that a lot of people may not know what a 45-70 is. It's a popular lever action round. So it's 45 caliber, and 70 refers to 70 grains of black powder originally used in this cartridge. I also like to promote other channels when I get that chance, so be sure to check out Leverguns 50 if you like lever action rifles. I put a link in the description to his channel. The 500 grain 45-70 bullet is huge. Compared to a 9mm or even a 45 ACP, that thing is giant. Now this 500 grain bullet comes in at 1.14 ounces, which isn't particularly heavy for a 12-gauge load. But it is a long bullet, and a normal 45-70 has a twist rate of 1 in 18 inches, and our shotgun has a twist rate of 1 in 36. Will we be able to spin it fast enough to stabilize it? The next issue is the bullet diameter itself. It's rather small compared to the bore size of a 12-gauge. The extra space in the bore is taken up by the 3-piece sabots. These also must transfer the spin from the rifling of the bore to the bullet itself. If the fit is too loose, the bullet will slip in there and not spin up to the right speed to stabilize. Now this is an obturator 12 gas seal. It's a piston more or less, and has a very thick center core, which I hope will help support that heavy bullet. On top of that, we put a cork wad. This will help cushion it a little bit and also provide additional gas sealing. And then on top of that, we'll put 2 pennies. Why pennies? A lot of people ask me that. Because I'm cheap? No, it's because they are a soft material and they will not damage the barrel. Hopefully the 2 pennies will be rigid enough to support that heavy bullet. And we're talking about very violent forces, 12,000 psi of pressure instantly pushing against all this stuff. We're going to break the budget in this video with our MS Paint animation. If we don't have really good support against that bullet, the entire wad can be pushed right past the bullet. An object at rest wants to stay at rest. The bullet is stripped out of the sabots and pushes its way right through all those components. And a good analogy of that is trying to drive a nail in with the palm of your hand. To have success, we have to drive all the components together as one complete unit. And even if we have a little bit of a setback where the bullet compresses against the components a little bit, we could still damage the sabot and not get enough spin or any spin to stabilize it. Our goal is to try to drive it to 1,500 feet per second, which will give us 30,000 RPM of spin. Now that sounds fast, but a 45-70 pushing this bullet at only 1,000 feet per second will spin it at 40,000 RPM. In the last minute, I decided to substitute the obturator 12 gas seals with an X12X gas seal. I'll do this with half of the shells and see if that makes a difference. You can probably tell that I'm a little bit skeptical about these actually working or not. It's a big challenge and I put a lot of thought into it. Well, let's go out and test them and see what happens. Once again, I'm out filming solo, and here I am setting things up and getting the shot aligned. Now, if you saw the last video of the gold tip slugs, we had a failure of the Chinesium belt, which was being used as a strap to hold the gun in place to control the recoil, and it just broke. And of course, I got a lot of suggestions from viewers on how to fix this. A lot of them were $1,000 solutions to what I saw was a $5 problem. And of course, there's some viewers that realize that I'm not a YouTube millionaire and came up with some budget-minded solutions. So therefore, we're going to try the $5 Harbor Freight tow strap and see how that holds up. I also have an additional belt just to back it up. Now, there's also a possibility that something else will break, maybe a weld or something on the stand. So we'll see how this setup works out.
Okay, you ready? Yes, I'm ready.
Let's take a look at the Chronos high-speed camera footage. You'll see a lot of junk flying through the air, so I needed to freeze it right there and show you where the bullet actually is. And what really surprised me is that bullet is very stable flying and just hit a little bit, maybe about an inch above the point of aim. So we're starting out pretty good. And to be just completely honest, I gave these things a very low probability of functioning. And I went out there with the mindset that this was going to be another failure video. So this was actually quite shocking to me. And this is what the bullet looks like after it was caught in the Kevlar vest. Just mushroomed out really nicely and embossed with the fibers from the Kevlar.
So many things to remember here. Here we go. Here we go.
Now all the white debris flying around is pieces of the SABOT. It is shattered, and somehow, by some miracle, we still transferred the spin to the bullet and had full stability. Now, this shot wasn't particularly accurate. We hit the jug, but at 20 yards, that's kind of miserable accuracy. And that accuracy issue could be attributed to just the way I have the shooting rest not set up properly. I probably need more weight on it. Or it could be because the SABOTs are shattering and the bullet isn't coming out of the barrel quite true.
Okay, I switched the lab radar to rifle mode. These might be going too fast for the range of the pistol mode. So we'll see if we can get a reading this time. Still no readings yet. Okay, got the stainless steel plate. Here we go. Wow. Here we go. Wow.
Now, as I watch the footage of me pulling that string, it does look rather awkward, and that does seem to be an issue as far as just supporting that stand to keep it from jerking around. But don't worry, I wised up and started putting some lead weights on the stand to see if that would help or not. And I'm the type that likes to verify if something will work or not work with my own eyes. Now, despite the lackluster accuracy again, it was a pretty impressive dent in that 1/4-inch stainless steel plate. Now, there seems to be no rhyme or reason to where the bullets are actually going. This one went low and left. The last one was high and left. But amazingly, the bullet was still spinning very well and very stable in flight. No tumble at all.
There we go. Still no reading on the chronograph. There we go.
Once again, the shot went really low and hit the 1/4-inch angle iron frame holding up the lead plate. Now in this shot, we could see all that extraneous debris. That's the big word for today, by the way, extraneous. Look at all the chunks of SABOT. How this thing actually worked is mind-boggling to me. And if you know me very well, you know that I don't have much faith in 3D printed components. The SABOTs were 3D printed and very brittle, but yet amazingly we still had spin and stability, which I thought we would never see.
Let's give it another try. This one's using the X12X gas seal. I wasn't sure how the Optuator 12 was going to work out after we had some fails a couple weeks ago. Let's see if that makes any difference or not.
Fortunately, we didn't see any major differences using the two different gas seals. This one more or less flew close to the last shot. It deflected off the angle iron base, and we did get a hit on the lead plate finally. Now, we're still not getting any readings from the Lab Radar LX, and I think that's because there's just so many metallic objects flying around, the pennies and all that are confusing it. But as you can see, we had a really good impact, very deep cavity. It did not penetrate. It's difficult to penetrate that lead plate with a lead projectile. But it was certainly very close to going through that thing.
For Eamon, put the dot right across the top of his spine and see if these things continue to shoot a little bit low.
Now, just when I thought I had this thing figured out and knew where to put the point of aim, well, the dang bullet went exactly where I was aiming, or close to it. Let's try it one more time.
There we go. I think that was a good shot.
Well, not much better, but an improvement over the last shot. Now, just for fun and curiosity's sake, let's move the target back to 35 yards instead of 20 and see what kind of accuracy we can get.
Okay, we put the dummy out at 35 yards. See if we have any kind of longer range accuracy with these. Got lead holding down the sled a little bit. Straps. I don't know if it's the stand that's screwing us up or just the rounds themselves. Okay, let's I believe I hit it.
I would have gone back even further than 35 yards, but I don't think we would have been able to see the bullet very well. But overall, I'm kind of proud of myself. I was able to hit this thing at all, especially with this unusual round. In this case, the elevation was really good. It just shot a little bit to the left of the point of aim. And we'll take another shot and see how we do with a two-shot group today. And the second shot did pretty well too. To my knowledge, this unusual setup using a 45-70 bullet in a 12 gauge SABOT round has never been done before, or at least never documented. And I'm also pretty pleased with myself. I was able to get the bullets to stabilize at all. This was a challenging one to me, trust me. As you can see, the two bullets hit just a few inches, maybe 2.5 inches away from each other. Although the rounds weren't particularly consistent accuracy-wise, these things do have a potential, maybe using SABOTs made out of nylon or something more resilient than 3D printed stuff. But we also have to look at the shooting rest. The straps all held on fine, everything. I had it tied down in the front too. Adding some more weight to it will probably help in the future. Overall, the rounds were not a complete failure. I'm pleased we were able to get the results that we did. Anyway, I appreciate you watching this and sharing this experience with me. give it a thumbs up or a thumbs down if you want. It doesn't matter. And let me know any other improvements that we might be able to make to this stand. Thank you again. We'll see you next time.